All right, so we're going to start looking at transformations by doing transformations of points on the coordinate plane. If you can transform a point on the coordinate plane, you can definitely transform other geometric objects, but it always starts with transforming points. So let's start with reflections. Remember, we're going to do reflections, rotations, and translations, okay? So here this says we're going to reflect point A, which is at the coordinates 5, 3, to another point that we're going to call point B over the y-axis, okay? Now, in this class, we're mostly just going to do the y-axis and the x-axis, okay? So we're going to reflect over the y-axis and the x-axis, but you actually can reflect over any line. So here's the y-axis right here. So the y-axis is going to act as our mirror. But we could also reflect over the line x equals 2. Okay, so we could also reflect over horizontal lines. We could reflect over the line y equals 6. Okay. So we're not limited to the y-axis and the x-axis, but in this class, that's what we're going to do. So we want to reflect this point A over the y-axis. Okay, so this y-axis right here is going to be our line of reflection. Now, I want to remind you that in a mirror image, that the closer something is to the mirror itself. So if this is the mirror, the y-axis is the mirror. If something is very close to the mirror, then the reflection is also going to look very close. If something is far away, like way back here, the reflection in the mirror is also going to appear very far away. So the closer that a point is to the mirror, the closer the reflection will be to the mirror, okay? And here's basically how we do a reflection. This horizontal distance between the y-axis, okay, we want to replicate that same distance there over here. So this is the length of the reflection. So this is how far we are from the y-axis. Here, that's 1, 2, 3, 4, 5. So our reflection is also going to be 1, 2, 3, 4, 5. And it's going to be in the same place looking at the mirror. So any point over on this side is going to be on the same y level over on the other side here, and it's going to be the same distance from the mirror. And so the distance is 1, 2, 3, 4, 5. So then we're going to come over here and we're going to go 1, 2, 3, 4, 5. And this is going to be point B right here. That's our reflection over the y-axis, which is the mirror. Okay. Now we can look at the coordinates here. This is the coordinates 5, 3, and now we can look at the coordinates over here of B, and it looks like it's -5, 3. So the coordinates here are -5, 3. So let's see what happened here. Our point 5, 3 transformed into the point -5, 3, okay, when we reflected over the y-axis. And so you can see what happened here. The y value stayed the same, but the x value became the opposite sign. It became negative. It was positive and it became negative. We can also assume that if it started negative, that it would then become positive, because if we started with point B, the reflection would be point A, and that goes from -5 to +5. So here's what we're going to say. When we reflect over the y-axis, all we're going to do is change the x, the sign of the x coordinate. All right, so write this rule in your notes. When you reflect a point over the y-axis, the original point becomes -x, y. So the y stays the same, but the x becomes the negative of. So if your x is like -3, your new x is just 3. But if your original x is like 9, then your new one becomes -9. All right, now we're going to reflect point A over the x-axis to point C. Okay. Now I want to remind you that this is the x-axis, the horizontal axis, okay? This is the x-axis, and so we're going to reflect point A over the x-axis to point C. And it's the same thing. What we're going to do is we're going to look at the distance, the vertical, this time it's the vertical distance between A and the x-axis, which is 1, 2, 3. So now from the same vertical line here, right along the same vertical line, we're going to go 1, 2, 3, and this is going to be point C. You can see that it's the same distance between to the x-axis as A is from the x-axis. And so we reflect A over the x-axis to point C. And so let's look at our coordinates again here. This A is at 5, 3, and C over here is at 5, negative 3. And so it looks like the thing that changed was the y-coordinate this time. It looks like this time the x-coordinate stayed the same, but the y-coordinate changed from 3 to negative 3. So let's go ahead and write up a rule for that. So here's our rule for reflecting over the x-axis. Whatever the coordinate is, xy, when it reflects over the x-axis, it becomes x negative y. So 5, 3 becomes 5, negative 3. Now we're going to move on to rotations. Let's talk about rotation here. So this says rotate point D, which is at 0.27, to point E. So start at point D and then make point E, rotating about the origin 90 degrees clockwise. Okay, let me unpack all of this for you. 90 degrees clockwise means that if your point starts in quadrant 1, you're now going to go to quadrant 4. So if you're here, 90 degrees clockwise means you're going to go over here. So here's quadrant 1, here's quadrant 2 or quadrant 4, this is quadrant 2 over here, and this is quadrant 3. Hopefully you remember that. So going clockwise means going this direction, okay? Sort of up and over to the right and then down and to the left, okay? So if this is clockwise, then clockwise means going from here to here, then going from here to here, then going from here to here, and then going from here to here. So if your point starts in quadrant 1, your new point is going to be in quadrant 4. If you start in quadrant 4, your new point is going to be in quadrant 3. Then from quadrant 3, you'll go to quadrant 2 and go from quadrant 2 to quadrant 1. Okay? So it depends on where your point starts as to where the new point is going to go. So what we can see here is that point D that we're dealing with is at 2, 7. So that's 2, 7. That's right here. Here's point D. And since D is in quadrant 1, we know that E, the new point, is going to be somewhere down here in quadrant 4. That's a 90 degree clockwise rotation. Okay? Now what does it mean to rotate about the origin? Well, remember we said that that when you're doing a rotation, there is a center of rotation. In this class, I'm almost always going to do the origin. In fact, as far as I plan, I'm only going to do the origin. The origin is the point 0, 0. It's right here. Hopefully you remember that. The origin is the point 0, 0. And that's how we can rely on this 90 degree clockwise going from quadrant to quadrant, because we're rotating around the origin. And in a way, what's happening here is we have this like hand of a clock that's moving clockwise. It's moving this direction, and it's centered at the origin. And so the new position of the clock hand will be somewhere down here in quadrant 4 because it's centered on the origin. Okay? And so here I'm going to show you how to rotate point D to point E about the origin by 90 degrees clockwise. 90 degrees clockwise just simply means that the first step is going to be in quadrant 1 and the last step is going to be in quadrant 4. So here's what we're going to do. You're basically going to go from the origin to the point. And do you remember the thing I said about distance where you count count in one direction and then count in the other direction, you're basically identifying the distance between the 2 points. That's what we're doing here. So from the origin to point D, we're going 1, 2, and then 1, 2, 3, 4, 5, 6, 7. So we're going to do that same thing, only we're going to do it into quadrant 4. But here's what we have to do. We have to rotate 90 degrees. So if we go sideways 2, we now actually have to go down 2. And if we go up 7, we actually have to go sideways 7. That's how we accomplish a 90-degree rotation. So 2 sideways becomes 2 down. 7 up becomes 7 sideways. 1, 2, 3, 4, 5, 6, 7. And so this is our point for E right here. Okay? And so that's what we'll do. We'll put E right here. And that is a 90-degree rotation. And here's how I can prove it to you. If I draw a line from point D to the origin and then draw a point from the origin to point E, look what it creates. It creates a 90-degree angle. And that's and it went clockwise this direction, and that's how we know that it's a 90-degree clockwise rotation of the point D. Okay? We'll do a couple more examples like this, but before we do, I want to show you, let's look at our coordinates here. This is 2, 7, and point E here looks like it's at 7, -2. Okay, so let's look at that. Okay, so point D was the point 2, 7, and now point E is the point 7, 2. So what happened here? What are we seeing? Well, it looks like the Y value from D has now become the X value from point E. And it looks like the X value from point D has moved over to the Y value, and it also became negative. Okay, and so this is what it looks like to me. It looks to me like point XY, which is D up here, transformed into Y, comma, negative X. See, let's look at it. X is 2, but over here the X is actually in the position of the Y, and it's negative, so that's why we have negative X. Y is 7, and over here the 7 is actually the first number in the X position, and so that's why we're saying that it's Y, comma, negative X. So I'm going to go ahead and write up a rule for this. All right, so here's our rule right here. Rotate a point 90 degrees clockwise about the origin. If it starts out as XY, it becomes Y, negative X. And so now we actually don't even need a coordinate plane to be able to rotate a point. If we say rotate point 27 90 degrees, well, I know that the point 27, if this is the point D, then the point E, I'm just going to take the Y value and put that first, comma. I'm going to take the X value and make it negative, -2, and we know that the rotation is 7, -2. Let's try another example. All right, so let's look at this example. It says rotate point F, which is at the point -3, -4. So here's -3, here's -4, so we're going to go to -3, -4 right here. That's point F, okay? And it says we're going to rotate that 90 degrees clockwise about the origin to point G. Well, I don't even need to use the coordinate plane. I can just use this rule. I know that my point -3, -4 is translating into the point, so I'm going to take the Y value and put it first. So I'm going to wind up with -4 first. Then I'm going to take my X value and I'm going to change the sign from negative to positive. So my -3 is going to turn into a +3, and I know now that point G is at the point -4, 3. -4, 3 is right here, and that's point G. And this point is a 90 degree rotation. And I can show you, look at this. If I go down 1, 2, 3, 4, and then over 1, 2, 3, now for this one I'm going to go over 1, 2, 3, 4 and up 1, 2, 3, and you can see that I have the point G the same distance from the origin, just like point F, only a 90-degree rotation. Let's look at the 90-degree rotation here. I'll draw a line to F, and then I'll draw a line from the origin to G, and you can see this 90-degree angle right here. So that's a 90-degree rotation. The other kind of rotation that we would do is a 180-degree rotation, and I'm just going to give you the rule for that. All right, here's the rule for rotating 180 degrees. It's really simple. If you want to rotate a point 180 degrees, if the point is at x, y, then the rotated point is just negative x, negative y. Okay? So if we rotate point F, which is -3, -4, to point G, which is 180 degrees about the origin, well, you can see that F is at the point -3, -4, so G is going to be at the point 3, 4. You just change the signs of both the x and the y. So G is going to be at 1, 2, 3, 1, 2, 3, 4. There's the point. There's 3, 4, so this is point G. And I can show you by drawing a straight line through the origin all the way to G. See, that's a straight line through the origin between F and G, and that means that that is a 180-degree angle. Okay, and that's it for rotation. Now let's move on to translations. All right, now moving on to translation. Let's do an example of translating a point. So this says translate point H, which is at the coordinates 4, 10. So here's 4 over here, and then we would go up 10 to here. So 4, 10 is this point right here. So we're going to call that point H. Okay, and it says translate point H down 15 and to the right 6 units to point J. That's all we're doing with the translation, is we're just moving in a vertical, maybe a little bit in a vertical direction and a little bit in a vertical direction, a little bit in a sideways direction. It doesn't have to be both. We can translate just down 15, we can translate just to the right 6, but this one's saying to translate both down 15 and to the right 6. Well, what does that mean? Well, that means from this starting point right here, we're going to go down 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so that's to here, that's to right here. Then to the right 6. 1, 2, 3, 4, 5, 6. And so this is our new location. That is point J. That is a translation down 15 and to the right 6. Okay, that's all translation means. Now you may be thinking, oh, this is the easiest one. You're right, translation is the easiest one, and I hope you benefit from that. So let's see here. H was at the point 4, 10. Looks like J is at the point 10 and -5. So 10, -5. Well, how did we go from 4, 10 over to the new point 10, -5? Well, let me show you. Do you see this down 15? Down 15, remember the y coordinate, this 10, is the up and down coordinate, and we're going down 15. So what we did was we took the 10 and we went down, which means subtract 15. Okay, so that's our new y coordinate. And our x coordinate, we went to the right 6. When we go to the right, that's adding numbers. That's our numbers going up. See, here's 1, and then to the right is 2. The numbers get larger to the right. And so that's plus 6. So our original x coordinate was 4. So we're going to do 4, then to the right, which is plus 6. 4 plus 6, that's 10. 10 minus 15, that's -5. And that's how we went from 4, 10 over to the point 10, -5. Is we took this translation, we subtracted when it was down, and we added when it was right. Okay? Now let's do another translation where we do up and left. All right, this says translate point J, which we're already familiar with. It's at 10, -5. Up 7 and left 13 units over to point M. All right, well, Up 7, that means add 7 to the y value. So we're going to do -5. Whoops, let me put it over here. We're going to do -5. Up 7 means plus 7. That's our y coordinate. Our x coordinate is going left 13. Well, when we go to the left, that's negative. So we're going to minus 13 from 10. So we're going to do 10 minus 13. And so it looks like this point M should become 10 minus 13 is -3, and -5 plus 7 is 2. So the point M should be at the point -3, 2. Let's find out. If we start at J, we're going to go up 7. So that's 1, 2, 3, 4, 5, 6, 7. That's to right about here. Then we're going to go left 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. That's right here. And so this point right here is point M. And sure enough, that point is the point -3 and 2. And so with translations, all we have to do is add to our y value if we're going up, subtract from our y value if we're going down, add to our x value if we're going to the right, and subtract from our x value if we're going to the left. So I'm going to go ahead and write this up as a set of rules. All right, go ahead and copy these rules into your notes. You can see that if we translate a point, if the translation tells us to go to the right h units. Now you may say, well, what is h units? H is just a variable representing a number going sideways. We do this in math all the time. If we're going sideways, we use h. If we go up and down, we use k. So h units is sideways, so that's right or left. K units is up and down, that's up or down. So if you're translating to the right a certain number of units, the x coordinate is you're just gonna add whatever h is, whatever that number is, to x. The x coordinate is just gonna become larger, okay? If you're moving left h units, then the x coordinate is gonna get smaller. You're gonna subtract h from x. If the translation is gonna go up k units, then the y coordinate is going to get larger. It's going to become y plus k. And if you're going to go down k units, then the y coordinate is going to be y minus k. So here's an example. What if we translate the point 23, 36 up 17 and to the right 9 units? Well, to the right 9 units means add 9 to the x coordinate. So 23 plus 9, that's 31. And up 17 means add 17 to the y coordinate, and 36 plus 17 is 53. So the translation from the point 23, 36 up 17 and to the right 9 would be the point 31, 53. And here's a summary of the rigid transformation rules. So make sure that these are in your notes, because these rules are going to be the basis of being able to answer a lot of the questions in this particular unit.